Oh, where's my paper? I don't know what I'm doing. Oh, here it is. Here. So, we're going to do this one. Okay. Whew. Going live. Now, what we're going to do is we're going to talk about this abacus. This abacus is what we're going to count. And here is my number. So I have my number 1, and so that's 1. So when I go 2, that's my 2. I have 2 on the abacus. What are we doing? We're counting on the abacus. When we count on the abacus, we're just trying to figure out how to read the abacus. So this is a counting tool. This tool helps me learn how to count. That's the beginning part, right? After a while, we're going to do some adding and subtracting, multiplication, division. Good morning, welcome, welcome, welcome. Or good afternoon. I know it might be early on the East Coast, but I'm on the West Coast, and so it's still morning for me. So here we have is 2. Oh, my abacus. So we have 2 on the abacus. And then we don't. We have 0 on the abacus. How do I know this is 0? Because none of the beads are touching this horizontal bar. With the horizontal bar being clear, being 0, then there's nothing here. But to do 2 is 2 like that. Welcome, welcome, welcome. Good morning. Come on in, come on in. I am happy you guys are here to learn about the greatest thing next to sliced bread. It's the abacus. It's actually one of the interesting tools to learn math. And why? Because you can see how everything works. So what we're going to do is we're going to talk about the abacus and why is this the greatest thing next to sliced bread? The greatest thing because we could see how we're moving the stuff. So this is 3. How do I know that this is 3? This is 3 because we have all these 3 beads touching this horizontal bar, or I call it the beam. So with this line that's right here, we can know that this is 3. It's easy to subitize. It's easy to see that this is 3. 1, 2, 3. Just like on a die. The die is easy to see that this is 3. That's one of the manipulatives that's being, taught in school. But what funny thing is they don't teach the abacus in school. And I don't know why. It's the easiest thing. Let me show you how easy it is. So again, this is my horizontal bar. This horizontal bar tells me which of the beads are counted. Now, if you notice, I actually started here on this column. Now, why did I start there? Because if you notice, I have a dot. I have a dot on my horizontal bar. This horizontal bar is telling me what beads are being counted. The dots, let me not be so bright. So the dots, if you see on my abacus, is actually a location. It tells me, now it's too dark. Now it tells me where I want to add the ones. Now I can do the ones here and it'll be easy to do, right? Because then we do 3. 1, 2, 3. You could do here, you could use this one here and then you would just have all these other beads to do the decimals. But I'm going to start here because then I can grow my numbers. So how does that work? Well, if you notice, we have our ones, our tens, our hundreds, our thousands, and our 10,000s. So I'm going to start here. Now, why here and not these two? It'd be like talking about money, right? When we talk about money, we can do 3. Let me redo that. We can do 3 and then 25. $3.25. So this would have the placement of the decimals. Welcome everybody, welcome. Let me know if you have any questions. What we're doing is we're learning how to count on the abacus. We're learning how to read the abacus. When we learn how to read the abacus, afterwards we will go into adding and subtracting. And what does that all mean? So the first thing we're going to do is understand that this is 3. So I'm going to clear my abacus. No, I'm not going to clear. I'm going to clear these columns. And the columns are 0. Right? So we know that none of these beads are counted. So we're at 3, and then our next number is 4. How do I know? Well, we have 4 beads. 1, 2, 3, 4. The idea is to know that this quantity is 4. All the bottom beads, anything underneath the horizontal bar is considered to have a value of 1. And then, but if you notice, we don't have any more beads for 5. What do we do with 5? Well, interesting enough, 5 will always be the top bead. The top bead will always be the 5. Always have the value of 5. So I need to change my little booklet to say 5. This is 5. Why? Why is the top bead 5? That's just the way it is. There's no rhyme or reason. There's actually a rhyme and reason, but like further on, when we start going into adding and subtracting, you'll understand why. But the first thing we need to do is understand that this is 5. So then the next thing would be 6. Well, what is 6? 6 is that. How do I know? Because we have 5 and we have 6. So it's interesting. Anybody have any questions, let me know. It's interesting because in school we actually teach the children how to carry on. In Abacus, we start to introduce the idea of counting on with the number 5. Because here we do 5 and then 6. And then here we do 5, 6, 7. 5, 6, 7. How do I know? Well, easy enough that we start to learn how to decompose on the abacus. Decomposing is also another kindergarten skill. And it's interesting because a lot of abacus is about decomposing and making into smaller numbers so it's easy to do. So what do I see? I see 5 and 2. 5 plus 2 is 7. So right here is 7. So already we're decomposing and already we know that we have 7. So then the next number would be 8. Now how do I know what 8 is? We have 1, 5, the 5, 6, 7, 8. So I count it on like a kindergarten skill, or I can decompose. 5 plus 3 is 8. Welcome everybody. Hi. Welcome. So what we're doing is we're counting on the abacus and we're trying to understand how does these beads work. So we have 5, 6, 7, 8. And then we have 9, which is easy enough, right? 9. That's always going to be 9. So we have 9 here. How do I know? 5, 6, 7, 8, 9. Why not start to the rightmost side of the abacus? Well, the reason why was because I wanted to start where the dot is, if you could see where the dot. So I have a dot right here, and this is what tells me that this will be the home. But notice there's 2 dots. So you can actually choose any dot you'd like. I like to choose this one because then I can have a lot of numbers, or I can choose this one and then I'll have a lot of small numbers. But with the dot tells me that this is the ones place. So when we look, we have the ones, the tens, the hundreds, the thousands, and the 10,000s. And then what happens after here? Well, just like we have money. Money. Okay, so just like we have money, we can do $9.25. Notice I have a decimal right here. That decimal does not take a place value. What it does is it sits, oh my gosh, sorry, I'm trying to rearrange my lighting. I can't understand why it just doesn't stay like this. Anyways, so we have, if I line up my decimal between these 2 columns, so I have my 9 and I put 20 and I put 5. So now we have $9.25. So that's why there's the 2 columns here. That's the reason why we start at where the dot is, and it tells us where. Oh, good. Thank you. Thank you for the question. But yeah, that's why I'd start, because there would be the dot here. And then you could use this one too. It doesn't matter. Okay. So going back to this, we have our 9. Now after 9, after 9, my daughter, I'm learning that right now. Oh, how to explain 14 minus 9. Yeah, okay. Let's go right in. You know what? Let me finish my thought, and we'll do 9, right? Just in case people want to know what 10 is. So 10 is 9, 10. Just how we write 10. Just like how we write 10. We have a 1 over here, which is the tens, and then we have a 0. So that's what we do with tens. Now, the question is, how do I explain to her what 9... Okay, before I continue on, we have 14 minus 9. Does she know her complements? Morwa, does she know her complements? We know plus 5 is equal to... So if I do plus 4 is equal to plus 5 minus 1, and then plus 3 is equal to plus 5 minus 2. Does she know this? Just a question. So I know where to start from. Morwa, does she know? Yes? No? Because we need to. This is going to be now a 2-step problem. Now, what does it mean by a 2-step problem? The idea is in Abacus we do foundation. So now we're actually jumping ahead, because I want to answer Morwa. The idea is she should know. I'm not sure she has it in her head. Okay, one thing is that she really needs to understand her how to make a 5. So one of the things in Abacus, just so everybody else knows, is that what we do is we learn how to make a 5. The one way to make a 5 is to do 4 plus 1 is equal to 5. Now this is a concept that we actually utilize, and we make it stronger. We make it really, we solidify this concept. So Morwa, with your daughter, this is great, right? We have 14, so we're going to add 14. But this is now a two-step problem. What does that mean? The questions I would ask, okay, we have 1 plus 4. Now we want to do is we want to take away 9. We understand we need to take away the 9. Question, I would ask her these specific questions. Do you have enough to take away 9? No. No. Let her answer it, right? No. Oh, how old is your daughter? Just so I know, the tone and stuff. Because if she's young, then it'd be kind of silly. But if she's old, then I'd be like, okay, this is what you do. I talked 7. Okay, so she's at a point where you can still kid around with her. What I would do is I would kind of make it like a little bit fun, and it'd be like, okay, can you add a 9? No, I can't add a 9. Okay, so now the question is how else can you minus the 9? So you have her think how to do things. Can I take away 5? No. So what I'm going to do is I'm going to minus the 9, right? Minus the 9 is minus the 10 plus the 1. We know that it's minus the 10 plus the 1. We know that we're going to take away the 10. So we take away the 10 and we plus the 1. Okay, that's the next step. Do you have enough to plus the 1? No, we don't. So what do we do here? The question is if we cannot add the 1, what's the next thing we do? We need to go to the 5. So can you add the 5? That's the next question. Can you add a 5? Yes, I can add a 5. Well, what do we do after that? How do we add this 5? So we know plus the 1 is equal to plus the 5 minus 4. So we remember plus the 5 minus 4. And that's how I do it. You could, if she doesn't know her plus 5 well, what I do have is I have a thing where you talk about cats in a tree. Maybe that will help. So one of the ones was we're going to do 1. Where's 1? So what did I do here is I added a thing called cats in a tree. And I'm just trying to be silly because I think having a story will help. So if the 5s doesn't work for her, right? If she doesn't understand, I'd say, okay, we had 4, right? And we want to do is we want to add the 5, we want to add the 1. We want to add the 1. Is there enough beads to add the 1? No. So what we're going to do is we're going to go to the cats in the tree. And that's where my fingers are. That's where my hand is, right? There's 5 cats in a tree. If there's 5 cats in the tree, I grab 1 cat. I grab 1 cat. I grab 1 cat. I grab 1 cat. 4 cats run away. So I go to the tree. That's my 5, right? And then 4 cats run away. And that's what I have my fingers. So you could try using your hands. And I think, because she's 7, she might like the story. So if I go to the cats in the tree, that's my hand. 5 cats are in the tree. I go to the cats in the tree and I grab 1 cat. But I only have a chance to grab 1 cat. 4 cats run away. Does that help? Let me know. So what we just did is we did a 2-step equation, and 2 we just did a 2-step equation. How is it a 2-step? We did 2-step because we did a formula, plus 10. We did a plus 10 and then a plus 5. So Morwa, did that make sense? Did that help to understand how to show how to do a 2-step problem? With a 2-step problem, it's interesting because we do have to combine when we learn how to do the 5 and we learn how to do the 10. So big thing is making sure that she really gets solid on the 5. If she is solid on the 5, then everything else is gravy. So what does that mean? Okay, so in Abacus, let's start off with understanding how do we add. Let's start off with how do we add simply. So in my book, whoa, that's not what I'm doing. Okay, so in my book, I have it where we start doing bead recognition, right? And we start doing like understanding how to do the combine the numbers, understand the numbers and the quantity. So here I have the abacus that says 2. I want them to write the 2 and so forth. So in this book, we only go from 0 to 9. But idea is making sure that they understand that we have, 4. So we have 4, and then we have to find the beads down the bottom. So that's what this is. So I have an activity to go through it, and then, we go into understanding like the relationship. Maura, did that help? Let me know. And if not, I can continue on with plus the 5 and the tens. So the next thing we do, I see you have nice materials to learn. Is this available somewhere to purchase? Yes, I have it on Amazon. So this one is the preschool one. But for you, what I would suggest, if she's not solid in plus 5, I would do the plus 5 with who. That's also on Amazon. And then I do the next one, which is the plus 10. And then I'm still working on the other ones. But the idea for this one is to get them to be familiar and not be so boring. Because abacus can be really boring. I'm just saying. I have 3 boys and they went through the boring abacus and I felt sorry for them, and whew, it was a struggle. It was a struggle to get them to like go through the abacus. So that's why I started creating activities. So before I continue on, so let me continue on with my thought process of adding. So the first thing we're going to do is we're going to add the 1. Now the idea here is knowing that we're going to add the 1, which is the second add-in. So when we add 7, we know that we add 1, this is 8. The idea here is making sure that the students know that they're only adding the 1 bead. That's what we want to know. We want to add the 1 bead. So when I have 6, I want to know when I plus the 1, it's only this 1 bead. That's all I'm doing. I'm adding the 1 bead. So the idea is that they don't label that the green will always be 1. They don't label that the red will always be red. That the 1 will always be red. So the question is, with group, she is on adding 3-digit numbers, but the topic, she still does have a problem. Yeah, it's fine that she's doing 3 digits. So can you give me an example problem and I will work it out with you? Give me an example from whatever she has, and I'll work it out with you, like how I would do it with my children. So I've been teaching abacus for about more than 20 years. I've taught like a few thousand kids. And now I'm trying to put it in through the internet and seeing if I can help anybody else to learn the abacus and so forth. I have created, and what I was trying to do is I was trying to modernize abacus, because a lot of the abacus that we have now is very boring. But also, abacus really relates to math that we do in school. And so if we understand how we do it in abacus, it'll be easy to do it in school. So thank you again, everybody. Welcome, welcome, welcome. Hey, Sonic the Rock Hog. How are you doing? I've seen you here. Let me know if you have any questions. Okay, so then what we're going to do is so one of the things I wanted to do was talk about, like, why do we want to know the plus 2? The reason why we do that is because as we look at our numbers, what we want to do is in abacus, we focus in on the second add-in. Now, when I was doing research on how do we teach our children, there was this one video I came across, and they were like, okay, 5 plus 3 is equal to 8. Okay, that's fine. But I noticed that their focus is different. Their focus was on the 8. Yay! They were like really excited about 8. And I'm like, okay. Now, why do I have discrepancies about it? Well, if I look at it on the abacus, I add the 3. I add the 5. So I add the 5. I'm over here. Why? Because I'm using this dot to do it. There's a dot on my abacus. So what I'm going to do, I'm just going to add the 5 here. And then I'm going to plus the 3. I'm going to add the 3, and I notice it's 8. I didn't add any formulas. I didn't have to say any formulas. She only has problems with the numbers, as I mentioned. Oh, okay. So let me continue on with this, and I'll show you some of the numbers that you can have her practice on. So so then again, we notice that we don't have any problems. We just add the 3. The next question we had was 7 plus 1, and again, they were really excited about this. The result, it's 8. It's 8. Okay, well, on the abacus we have 7, and then we have plus 1 is 8. That's fine. That's not a problem. But what we did is we actually added in different numbers. Now the next question, and I don't know if anybody knows, the next question was 4 plus 4. Now 4 plus 4, we do a lot of memorizing the doubles, but there's no rhyme or reason why to memorize the doubles. We just know we add the doubles. And again, the answer is 8. And it's like, yeah, this is 8. But in Abacus, it's a little different. In Abacus, we have 4, and then we don't have enough beats to add another 4. This is why we focus in on the actual add-in that's right here. This is what makes it different. The second, the number that adds to it is what makes it different. Now, Abacus is the gateway to complex math. Why? Because in the beginning part, and I noticed when we start talking about it in school, in the earlier grades, we always focus on the result, but we never focus in on the process. But in Abacus, we actually focus in on the process. So let me finish this thought process, Morwa, and I'll continue on with the numbers that she was having problems with. So again, what we're going to do is how do I add the 4? Notice I don't have any beads to add the 4. One of the things we need to memorize in school, in Abacus, is plus 4, and the concept of plus 4 and plus 5, 4 plus 1 is equal to 5. This is something we have to memorize. Why? Because it's a concept. This concept now turns into a formula. Plus the 4 is equal to plus the 5 minus 1. So now what we want to do is understand what this formula means. This formula means when I want to add the 4, right? When I want to add the 4, this is the 4 I'm adding. What we just did here is we isolated the variable. And we're going to substitute the plus the 5 minus the 1. So we're going to substitute this equation, this formula, into here. So now we're starting to do a little bit of algebra. It's an introduction to algebra. It's not full-on algebra, right? We don't have x's and y's, but we have concepts underlying what algebra is, right? So we have plus the 5 is equal to plus the 5 minus the 1. Why do I say plus 5 all the time? Because we're using an operator to add. This is a gentle reminder that we're going to add. So when we do is we plus 5 and we take away 1. So that's why we do plus 5 minus 1, because now we're being balanced. Oh, that makes sense, because yes, exactly, because 4 is equal to 5 minus 1. So when we look at it, minus 4, and then we try to balance it out, right? But we say plus 5 because what we want to do is we want to add the 5. Okay? So one of the things to know is this is a fundamental formula, equation, building block that we need to memorize, because now it can go anywhere. So if I have the question easy, right? 3 plus 4. We don't do doubles. We don't say, oh, it's a double minus 1 or it's a double plus 1. We don't say any of that. What we do is we have a 3, and we want to plus the 4. How do we plus the 4? Is there enough? No, there's not. So what do? We will go back to our formula that we've memorized. Plus the 4 is equal to plus the 5 minus 1. So I want to plus the 5 minus 1. And now I've used what I've learned. We didn't do doubles. We learned our building block. Our building block is plus the 4 is equal to plus the 5 minus 1. Okay, so now we know a little bit about that. So Mora, what we're going to do is we're going to continue on with the problem. I feel like this could be helpful if I started my students in first grade. You know what? It does help. It does help. I have students from kindergarten, from preschool, but the reason why I did preschool because we don't teach that we didn't teach it in Abacus class. So what I'm doing is I'm taking 2 steps back to try to get the kids when they're younger. But you can absolutely introduce this to the children in kindergarten, first grade, second grade, and even go into third grade depending on their attitude. But like I'll have students that will be 9, 10, 11 years old. And the only caveat is making sure that you go through the motions. So it's easy to be like 2 plus 2, right? Oh yeah, I already know what 2 plus 2. Why do I have to do it on the abacus? So, as a child gets older, they're not understanding why we're seeing it. But when the questions get harder is when they start seeing the benefits. So it's kind of like, do you weigh it out and so forth? So the first thing because they're in first grade, it'll be easier to introduce, to say, okay, let's start to learn how to read the abacus. right? We have 1 and 2. Why? Because it's the same thing of using a die. And you can kind of correlate the die, or if you're introducing the building, the number blocks, you could say, okay, we have the number blocks, how are we going to do this? Well, what number is this? We know that this is 34. How do you show it on the abacus? Well, we do 30 and we do 4. So that was the thing. But as a tutor, my 3rd, 4th, and 5 are too far along to add this to the curriculum. Not necessarily, because they're 4, 5, and 6, they're going to start doing their double digits and triple digits, and you can still include it. You just have to find bigger numbers. So in the one of the questions, you could do 721 plus 200 225. You could do something like that, and that would be a simple thing. So what does that mean? So I do my hundreds, right? So I do my hundreds because it's 700. So I'm going to add 700, and I'm going to add 20, and I'm going to add 1. And then what is my next number? Well, I need to add 2. Is there enough to add 2? Yes. So I'm going to add the 2, and then here I add another 2, and then here I add another 5. So you could start from there, I'm assuming that the abacus for 5, 6, 7, 8, 9. I'm assuming there is an abacus for 5, 6, the grades or the numbers. So when we do the numbers, it's 5, and then 6, 7, 8, 9, and then 10 would be this. If you're talking about grades, the numbers, yeah. So that would be the numbers. So this is the number. They only go up to 9. And then because of this, when you start doing the adding and subtracting, you can do multiplication, division. So when you get to your 3rd, 4th, and 5th grader, they need to really know their multiplication fact. Because they know their multiplication fact, we can start. You could start doing multiplication and division on the abacus. But let me continue on with Morwa. Some of the questions you want to try to do is focus in on the two-step questions. So here would be 15. You said, sorry, so it wouldn't be 15. It'd be, so some of the questions that I would focus in on would be 13 minus 6, right? Why? Because it's the same thing. Now we do 13, and then we take away the 6. Well, how do you do minus 6? Minus 6 is minus the 10 plus the 4, right? We know this. So we're going to take away the 10, and we're going to add the 4. So the one question I'd focus in on, how do we add the 4? Is there enough? No, we cannot add the 4. So this is when we start saying, okay, when we want to plus the 4, it's equal to plus the 5 minus 1. So I plus the 5 minus 1. And my answer is 7. So there's specific questions. Marwa, are you teaching your child, or is a teacher teaching your child? So that's the other question. Because, obviously if a parent is doing it, it's just, the resources and trying to figure out the resources and the things. So yeah, Maura, can you let me know, do you have a teacher or a tutor that's teaching your child? Or are you doing it? I mean, it's okay if you're doing it. I didn't teach my kids. I'm just letting you know. There's so many things I want to teach my kids, but my abacus was not one of them because I couldn't handle the complaining. So going back to Rachel. So was there any other questions about, like, with the numbers? And then here you can actually do decimals. Now, how do I do decimals? Well, the decimal sits between the two columns. So we have, when I had my example over here, we have 9.25. So because the kids are older, you might want to transition to a higher, or not higher, but an abacus with more columns. So this one is a column of 13. And you can have one like this that's like 13, but then I think this is a little bit, it's really colorful. It gets really overwhelming if there's 13 of them. I would probably use this one. Like, maybe the first graders would enjoy this because the numbers will still be small. But then with the 3rd, 4th, and 5th graders, I would transition to a single colored 13 columns. Because here, now we're going to start being able to start in the middle, and now we have all these numbers to be a bigger number and all these numbers to be a smaller number. Teacher, in Poland is new method. I don't know all the stages. Oh, that's very interesting. That's very interesting. Okay, so here are the stages of abacus. The first thing we do is we understand the simple abacus. What does that mean? Simple abacus means that there's no formulas, right? So that's the one thing, understanding the simple abacus. So I think in abacus world, we call it simple. Why do we call it simple? Because if we look at it, we have, I'm going to do minus because I don't do a lot of minus. So I'm going to do minus. So the simple means, do I have enough beads to add to, do I have enough beads to take away? Right? So here my number is 7. So I have 7. Can I take away 2? Yes, I have enough beads to take away 2, so I'm going to take away 2. Right? So it's easy. There's enough beads, then we're okay. That's why these are green. Okay? That's why these are green. The next number that we need to start figuring out is, how do we utilize the 5? How do we figure out to make this 5 work more for us? Yeah. How do we make the 5 work more for us? Because it's great to look pretty, right? It's great to look pretty, but on the abacus, there needs to be more than that. I crack myself up sometimes. Anyways, so why do we want to do this? Because we want to be able to utilize the 5. The 5 and the 10s are heavy hitters. Why? Because you can actually do more. There's a lot of numbers that you can deal with when you know those fundamental equations. Now, those formulas that we're talking about, now when we look at it, we do 4 plus 1 is equal to 5. The next pair to make a 5 is 3 plus 2 is equal to 5. Knowing this, right, we can do so much. But don't forget, because we have the plus here, it's assumed that this is going to be a plus. So if this is assumed, then we're going to know that we could do minus, the opposite. Minus 4 minus 1 is equal to minus 5. We can do minus 3 minus 2 is equal to minus 5. Why do I do this? Because I'm talking to adults. Are there other abacus where the top bead of the line represents? Are there abacus? There is this abacus, which is a Chinese abacus. I'm not sure if that's what you're talking about, but no. The top bead will always be 5 no matter what, no matter where you are. So on the abacus, on the Chinese abacus and on the Japanese abacus, 5 will always be this. This is, so when we count it, right, when we count, let me do side by side. When we do counting, we have 1, 2, 3, 4, 5. 1, 2, 3, 4, and then on the Japanese abacus, this is 5. On the Chinese abacus, we have 5 or 5. It doesn't matter. They're both the same. And then it gets really kind of confusing because you can end off here, but then it's an extra step. So we have 5 or we have 5. But 6 is the same. That's 6. So then 5, 6, 7, and then 8, and then 9, and then there's 10. With 10, this is, now we're breaking the logic. Because it doesn't make sense. Because if I use this as my place value, this is 10. This will always be 10. When I write it, this is 10. 1 and a 0. But now with this Chinese abacus, this is 10. I'm like, that doesn't make sense. Because you can have this as a 10, or you can have this as a 10. Or you can have that as a 10. Which now aligns with being logical, right? Because we have the 10s over here, and we have the 1s over here. So in the Chinese abacus, there's 3 ways to understand what 10 is, and then you have to start thinking, okay, which way are we, what are we trying to do here? So it takes a little bit of time to like understand and recognize. So I'm not sure the top bead of the line represents 2, 3, or 4. No. So like if we do here, if we're talking about the top bead, this is 5, this is 5, and then this is 5. These will always be 5. It just depends on where we are on the abacus. So this is 5, this is 50, or this is 500. This is 5,000. Did that make sense, Rachel? So the top bead, and it matters on not necessarily the top bead, but the columns of the abacus. So I have my ones, my tens, my hundreds, hi Emma, my thousands, and then my 10,000s. So when we say the line, we're talking about, oh, that makes sense. I was thinking that there was an abacus that I was thinking that there would be an abacus that breaks a number other than 5. No, there's one that's an abacus that goes 10 across. I don't know how to do that. I don't teach that. But I would assume it's the same thing as having like all of these in the same area. But no, you don't break the 5. That's why, you know what? That's why I added this thing called the cats in the tree. The cats in the tree. Because you don't break the 5, you just understand the concept of how to maneuver, how to use it. So that's why I have cats in a tree. And we use and you can use your hands to signify it. So if I want to do 4, I want to add 4, I grab 4 cats, and then 1 cat runs away. And so that I actually use my fingers, my hands more when I talk about the 5, because that's a new concept. And with the new concept, it's easier to do the other concept, which is minus the 5. And then after that, it would be plus the 10, minus the 10, and then mixing the two. So Morwa, as I said, you would figure out how to do the plus, right? And then solidify the plus 5. This is the same as plus 1 plus 4 is equal to 5. And then plus 2 plus 3 is equal to plus 5, right? And then it'd be the same thing here. Minus 2 minus 3 equals to minus 5. And minus 1 minus 4 is equal to 5. When your daughter looks and she needs to memorize, plus 4 is equal to plus 5 minus 1. And I would suggest her say it out loud, because the more we listen, the more we understand. So, because 5s and 10s make sense because doubles, and 6 ends up being 6 plus 1. Yes, exactly, you're absolutely right, Rachel. 6 ends up being 5 plus 1. So then you can start decomposing, and so that's what Abacus does, is it introduces also the idea of decomposing. So when we have 6 or we have 8, 5 plus 3 is 8. So I'm continuing on. When she learns, she needs to memorize that 3 plus 3 equals plus 5 minus 2. That needs to be solid. So then we have plus 2 is equal to plus 5 minus 3, and plus 1 is equal to plus 5 minus 4. This needs to be solid. So then when she does the opposite, if I want to find minus 4, we have minus 5 plus 1. Here we have minus 3 is equal to minus 5 plus 2. If we have this one, right, we still need to go down the process. Minus 2 is equal to minus 5 plus 3, and then minus 1 is equal to minus 5 plus 4. So Morwa, I don't know if you're still around, but I would really get her to say it out loud and to talk about it. So Rachel, when you start going through it, the first thing I would do is talk about like the simple stuff, right? So the simple adding and subtracting, which would just be adding what's on the thing. And then the next step would to be learning how to make a 5. Everything always diverts to a 5, plus or minus, yes, and also a 10. So the other thing is understanding how to make a 10. Because that's when we start doing regrouping, borrowing, carrying over, and grouping. So why do we need to know the plus 10s? We call it plus 10s. But in regular school, we call it grouping, regrouping, and carrying over. So we know in school we do plus 9 and 1 is equal to 10, and then 8 plus 2 is equal to 10, and then 7 plus 3 is equal to 10. We know all of this, right? So we do 6 plus 4, and then 5 plus 5. I'll stop here because that's not a good 5. Well, I'll stop here because we can do the reverse, right? Oh, okay, yeah. Yes, I'm here and I'm listening. So I don't know what else to say about. I mean, that's what I would do, is I would have her focus in making it and saying out loud the plus 5s, because when she says it out, here's another thing. When you're doing the problem, let's say 13 take away 6, have her say the formulas out loud. I want to add that. So just as I tell you, right? 1 plus 3, not a problem. Minus 6. How do I minus 6? And I would have her say it, right? It would take some time for her to get used to it, but I'd have her say it. Minus 6. Minus 6 is minus the 10 plus the 4. And I would say it, I would point to it. Because it's one thing to see it, and it's another thing to get mixed up in our heads, right? So what it is we have a voice, we should use it. Minus the 6, I want to be here. Minus the 6 is minus the 10 plus the 4. And I'd say it. Minus the 10 plus the 4. Minus the 10. Oh, so Rachel, this would be the carrying over. No, borrowing. This would be borrowing. Because we're going to take away the 10, minus the 10, and then plus the 4. Now, how do you plus the 4? Plus the 4 is plus the 5 minus the 1. And I'd have her say it out loud. Plus the 4 is plus the 5 minus the 1. And as she starts saying it, she'll start understanding and realizing what she's doing. So with Rachel, I just want to let you know that that's how we do carry. Yeah, it was like grouping. What was it? Carrying over. We start the idea of carrying over with the simple idea of doing the plus 10s. Borrowing, which we don't really borrow, we just take away. So when we start looking at this, the same concept. When we try to isolate the 9, we want to move the 1 over here. This is when we want to plus the 9, right? So if it's plus the 9 is equal to plus the 10 minus 1. Now there's also a reverse. There's the minus the 9 minus 1 equals minus 10. And again, we're going to isolate this variable. We're going to move this 1 to this side. And we're going to make it even. So it's minus 9 is equal to minus 10 plus 1. Now, when I have my example here, I'm going to do a 9 because it's easiest since it's the most numbers. So I have it where I do 9. Okay, let's do this one. So I also have it in another story. Oh, I'm pretty sure she doesn't see that. No, yeah. Thank you. I'm pretty sure she doesn't see it. Yeah, so it's one thing to see it. It's another thing to be because math is a lot of numbers, right? And we get kind of muddled in our head. So sometimes when we say it out loud, it's easier to track what we're trying to say. So going back to here, what we're going to do is we're going to add the 9. We're going to add the 9. So the idea is to know what we're doing here. Now we have the 4. I'm going to start over here. Hopefully you can see that. Okay, we're going to add the 4, right? My sample question is plus the 4. Now I want to plus I want to plus the 9. Now to plus the 9, what do I need to do? The formula is plus the 9 is equal to plus the 10 minus 1. This is something that the kids will have to memorize. You can explain it like move it over and blah. That was for this. Doing this is for adults because we want to know. I want to know why. I want to know why I'm doing this. For the kids, do they care? I don't think they care why they're doing this. So I would just say memorize this. This is the one thing that they would have to memorize. And I would have them chant it out. Plus 9 is equal to plus the 10 minus 1. Plus 9 is equal to plus 10 minus 1. And also say the operators in the front because that's a gentle reminder that we're adding to it, right? So here, we want to add the 9. We want to plus the 9. Plus the 9 is plus the 10 and then minus the 1. And then my answer is 13. Oh, so the reason why I have this is to talk about an asteroid belt. So if I have 4, do I have enough to plus the 9? No. So I got to go to the asteroid belt. The asteroid belt I got to go is to add the 10. I go to the asteroid belt. I go to the asteroid belt, but that's too many, so I have to minus the 1. So what I would do is go to the asteroid belt, add the 10. And then what do? We have to take away the 1. That's what I would say. Take away the 1. And my students were able to pick that up. So let's do 3, right? We add 3 on the abacus, and then we plus the 9. Well, how do we plus the 9? Well, we got to go to is there enough? No. So what do? We go to the asteroid belt. That's over here. We go to the asteroid belt, and then we take away the 1. And then you'll notice the students will notice that there's now going to be a pattern. If I want to add the 9, this is what I do. If I want to take away the 9, this is what I do. So you're going to start seeing patterns, but you won't see it until you go through the questions, and you got to go to the questions one by one. You could have it where, oh yeah, you can do like you can group it, right? Like here, oh, I know that 7 plus 7 is 14 plus 1. You could do it, but then you're defeating the purpose of moving the beads to see what you're trying to do. Does that make sense? So, I mean, there's a lot of shortcuts, right? Like here. Oh, this is 9 plus 9, take away 7. Oh, I just need to take 9 minus 7 is 2, and then just take away the 2. You could do that, not a problem, but then you defeat the purpose of understanding how to move the beads. So when we do it on the abacus, we do 9 and then plus another 9. Again, not doubles, right? So what we need to do is we need to add 9. Is there enough? No. I want to plus the 10 and then take away the 1. If you go through it and you barrel through and just say, just do it, you won't see the actual process of moving these beads. So you have to go through and move the beads so you could see what number pattern is being solidified. So that is the reason why I'd say just go through step by step. Don't be like, oh, I know 3 minus 2 is 1, so I don't need to do it. No, the idea is, okay, I want to see it, and then I need to see that I take away the 2. It's a little bit elementary, but the idea is to make sure that they can see the beads, because when they see the beads more, they will be able to manipulate it a lot quicker. In the beginning, it will take time, but as they get it and they understand how the beads move, it will be faster and easier. So then again, I want to plus the 9. There's not enough beads to plus the 9. So what do? Again, have them chant, plus the 10 minus the 1. I hope that helps. Yeah. Thank you again for everybody joining, and thank you again for following me. But we were talking about, so these are, I mean, it might be, it's elementary for us right now, but understanding that the steps are there, slowly go through it and start building it. One thing you're going to have to deal with is, because the kids are older, that you're going to be like, they're going to be like, I already know this. Why do I need to do it? Why do I need to know it? The idea, I don't know how you're going to answer it, but the idea is that they need to go through the process just to see how the beads move. And that's the one thing, like, it's hard to, in the beginning, I was like, okay, just do it. But then as I started thinking about it, it's really, you got to go through the process to see how the beads move. Yes, it will be easy. Yes, and if it's easy, that's fantastic. If it's easy, fantastic. Why? Because then we get solid and they become happy about it, right? So when you start doing it, they'll be like, oh, 5 plus 3, I already know what that is. Oh yeah, or 3. Oh yeah, that's 8, right? How does multiplication work? Okay, so multiplication is a little bit more, because one, you have to build from adding and subtracting, right? So we built our adding and subtracting over here. I'm just checking to see what I have. Okay, so again, we do multiplication, adding and subtracting, right? But we know, when this is solid and you understand that there is this, there's a two-step. There's a two-step, meaning that we combine the two. Okay, that's all square and done. Now let's do multiplication. In Abacus, we actually don't do okay, sorry. I'm going to go to the next one. Amma, you said, would you recommend the 7 row or the 13 row for an adult? I would recommend the 13. For an adult, I would recommend the 13. It's nice to see how a teacher explained that we were counting 10 as a 1 and then imagining that there's a, yeah. It just depends on how I really think it's the greatest thing next to sliced bread, but I also really enjoy explaining these concepts. So, Amma, I would do 13 because then you have more beads. Transformation, and there was a counting one by one till we will add all. Continuing to count till we add all. Oh, like a number line? Like this? Like a number line? It'll be 1, 2, 3, 4. If this is 1, 2, 3, 4. You could. I'm not sure. See, Abacus doesn't do the number line. It just doesn't, it wouldn't make sense. I show it. I show the number line in my thing. I show my number line in my book. The only reason why is because in school we show number lines. But I don't focus in on the number lines. It was just meant to it was just meant to show and demonstrate there's other ways to learn it. But I don't focus on the number lines. What I do focus in is understanding their hands and stuff. So, oh, my way makes sense. Oh, great. Hey, oh, Debas, the basic addition hand movement algorithm is super important to multiplication. Yes. Yes. So we're going to do multiplication. Now, the one thing I want to let you know, in Abacus, we actually don't know more than 10, no more than 9. Just so you know, we don't memorize our 12 times table because it's redundant. So the first thing we're going to do is I'm going to do a simple one, right? So we can track and I can show you, because if the number gets too complicated, then we're doing too many things. So the first thing I'm going to do is let's do 12 times 7. Let's do 12 times 7. 12 times 7. Easy. Easy peasy. What do? I will count. Now, the reason why I'm doing 12 times 7 is so we can see it, right? So in school, we're doing this, which is fine, and we can do it. And then okay. So in school, we do the ones first, and then we do the tens. That's fine. We could do that too. But for right now, I'm going to show you how to do it on the Abacus. So what we're going to do is we're going to count the amount of digits. Why? Because then we know where we're going to put our answer. And I'm going to finish this, and then I'm going to have to go. So why do we need to know how many digits? Because I want to know where I put my answer. My answer is going to be in the hundreds. Why? Because I have 3 digits. 1, 2, 3. 1, 2, 3. I'm at the hundreds now. So I know I'm going to put my finger here. I'm going to use my finger to track where I'm going to put my number. So the first thing I'm going to do is I'm going to do 7 times 1. 7 times 1 or 1 times 7. Doesn't matter, right? But it's a single digit. Because it's a single digit, I'm going to modify this a little bit and put a 0 and a 7. Why? There's a leading 0 because I want to make it double digit just so we can see. So what happens? It becomes a 0 and a 7. So now I move my finger to the next column, to the tens. Why? Because now we're going to add 7. So I'm going to add 7 to the tens column. Now I'm done. So what do I do now? I'm sorry, I forgot my arrows. I'm going to do that one. I already did that one. Now my next one is 7 times 2. 7 times 2 is 12. 14. They need to know their math facts. For hands down, you could do cumulative addition. You could do it. I did it for my kids because I didn't want them to memorize, but they got tired of doing cumulative addition and then they started memorizing it. Anyways, it was just one of those sadistic things that a mom wants to do, right? Anyways, so we're going to add 14. We add 14. We add the 1. So again, it's double digit. Right? We add 14. We add the 1 and then we add the 4. And that's it. That's all I got to do. Right? So what we just did here is called distributive property. And that's a concept that is being taught in algebra. And in algebra, they know that they have to go through one at a time. Did my kids have a problem with algebra? No. But they didn't know why. They just felt like they knew it and they don't understand why. Like to them it made sense. But it's because in Abacus we show them how to do it. We solidify this process of doing distributive property. Did that make sense, Rachel? So that is why we don't memorize our 12 times table. We only go up to 9. So, going back, we can do more multiplication. 34. It's not right. No, it's not 34. It was 70. I gotta look. So, I do 1, 2, 3. I add the 7. And then I add the 14. No, that's not 7. That's 7. 7, and I had 14. 84. 84. Because we forgot the 5. Maybe I moved my abacus and the 5 moved. That's why you got to hold the abacus. That's the reason why. So no, it's 80. 84. Right? Yeah, 84. Oh, or it could have been that I moved my abacus and then all the beads move. So, okay, one last question. We'll do another multiplication question. Just to get an understanding. We can do the 2 to, oh no, I was going to do the other way. So, okay, I was going to do the other way. I was going to do this way. 12. So in school they do in school they were doing 12 like this. I'm going to make it nice and big. Times that, right? And we have to line it up just to make sure we understand, right? So we could do it, not a problem. Now, we will start here. So what do we do first? Well, okay, we got to do 2 times 7 is equal to 14. So it's kind of backwards because now we got to go here to go here because we don't say 4 and 1. We don't say 4 and 1. What do we say is 14. We add the 1 and we add the 4. Right? So I'm always playing around with the lighting on this stupid camera. Sorry. So this is why it's a little, to me, it's backwards. Right? So we do 14. We do 14, but we don't say 4 and 1. We say 1 and 4. So we got to go 1 step forward to go 2 steps back. So I got to add 1 and then 4. Right? Okay, fine. But now I'm here. What I need to do is go here. Okay? And then I do 1 times 7. 1 times 7 is 7, so I add my 7. You could do that. You could do it. But this is simple, right? It gets kind of hairy when the questions become 4, 3, 5 times that by 48, 9, right? Then it gets really hairy. Ooh, and that's kind of complicated. I'm not gonna lie. I mean, doing it this way would make it really complicated. Then you would really have to do long multiplication. But you could do it in Abacus. I don't have enough beads right now because what do? We have to count the amount of digits. So it'd be 1, 2, 3, 4, 5, 6, 7. It'd be 1, 2, 3, 4, 5. I only have 5. So I'd have to use this one, right? So it'd be 1, 2, 3, 4, 5, 6, 7. And that's where I'd start. And then it'd be the same process. It'd be 3 times 3, and then 3 times 4, and then 3 times 3, and then 3 times 5. See, and then this is how we solidify our math facts. Like, they really need to know their math facts. When they're done with this, you regroup. You reassess. How many is left? 1, 2, 3, 4, 5, 6. So then we start in the sixth column. 1, 2, 3, 4, 5, 6. I'm just kind of blowing through because I'm going to leave soon, actually. This is just just give you like the concept of like how to do multiplication. So then from here we do 3 times 4, 3 times 4, 4 times 4, 3 times 4 again, and 3 times 5. Okay, we're done with the 4, and now I can see how this helps with thinking for algebra. Yes, Abacus is the gateway to complex math. There's a lot of things that we do in algebra that we do in Abacus, but we don't. But you know, funny, in Abacus we don't label all the things I'm talking about, like grouping, regrouping, carrying over, and borrowing. We actually don't say that in Abacus. We just say plus tens. Okay, so we're here, and again we gotta reassess. We have 1, 2, 3, 4, 5, because we already did these two, so we're at 5. So it'd be 1, 2, 3, 4, 5. So we'd be here, and then it'd be 5 times 8, 8 times 3, 8 times 4, 8 times 3, and 8 times 5. Rachel, did that make sense? I know I was blowing through it. I just want to make sure you understand before I head off. I will come alive again. I'll come back on alive again. I go live all the time. Alma will let you know. I love talking about Abacus, and I love the questions. The questions are fantastic because it makes me think about like how to explain certain things, because I've been teaching Abacus for 20 plus years. I've been teaching Abacus for 20 plus years, but I've been teaching it to kids. So it's not like they have a concept of what was before and what was after. I mean, I know as a child, but the last time I did any sort of adding and subtracting was more than 20 years ago. And I actually didn't have to help my kids. So when they had a problem, I used to be like, you know what? Take out your Abacus and do the problem. And then they did it on the Abacus. So one of the questions, you know, they had problems with like adding and subtracting or whatever on like, if they couldn't do it in their head and the way they write it, then I say, you know what? Take your Abacus out and show it to me. And then they will see that it correlates from what we do on the Abacus to what they were trying to do. So now my problem is, just so you know, one of my kids, my youngest kid, doesn't show his work. And I'm like, just show your work. Just show your work. You need to teach the teacher because the teacher doesn't know what's going on. So you need to show your work. And I'm trying to push him to show his work, but he does what he does. It's one of those things that it's just his personality, but I keep making him say, just show your work. And that's the one thing, like I wanted to show how it relates to Abacus. How does Abacus relate to mainstream math? And it makes it really easy to understand if you knew, you know, why we're doing certain things, right? If I didn't explain why we're doing it, then it would be, what's the point? What's the point of learning? Right? So, sorry, I was just looking at my phone for seeing if I have any messages. So, before I leave, do we have any other questions? Um, any other questions I can answer? I don't know if Marwa is around. I don't see who is around. I just see that there's 9 people. Oh, hey, multi-universe delicious. Thank you very much. Yeah, you're welcome. Turn your notification on and you will get notified when she's alive. Yes, thank you, Mama. Thank you so much. Turn your notifications on and you will be notified when I go live. I go live all the time. I do enjoy it. I enjoy everything about talking about Abacus and how simple it is. And I understand how, like, we're starting to make it more complicated, and it doesn't really need to be. So there's, I mean, even in school, they're like, well, you need to make a 10. So the question was like, 549 plus 782, and then they're like, okay, well, how do you make a 50 out of this? So it's like 50 plus 80, right? Now they're doing some sort of other rounding. So I have to remember in my head that I'm going to add 1 here, so I have to take away 1 somewhere, and then I have 700, and then there's a 2 somewhere. And then they're like, okay, now you can modify it and make it all better. It's like, okay, so then what is it? It's 350 plus 780 minus plus 1, because what I do, I took away the 1 here and I added and I took it away from there. So then I can do, you know what I mean? And it's like, that's great. But on the abacus, right? On the abacus, as long as you knew how to do the plus 5 and the minus 5, everything is gravy. So if we do it on the abacus, it's 349 and then plus 782 plus 7. How do I plus 7? How do I plus 7 on the over here? Plus 7 is equal plus the 10 minus 3. So I plus the 10 minus the 3. So now I want to add the 8. Is there enough? No. I want to add the 8. So plus the 10 minus 2. So I plus the 10 and I take away the 2. Now I want to add the 2. Is there enough to add the 2? No. I have a 9 here. So what do? I will use today what? Oh, yeah, fantastic. Good luck, Morwa. Good luck. Let me know. Let me know how it goes. I'm really quite interested. So I want to plus the 2. If I want to plus the 2, I cannot add the 5. So what's my next step? My next step is, can I add the 10? Yes. So plus 2 is equal to plus the 10 minus 8. Again, if you notice, there was a framework. There was critical thinking. There was critical analysis. There was an analysis that I did. And this analysis helps the kids to formulate what they're trying to do. The real question is how do I? Right? Is there enough? How do I? So mine is, how do I add 2? I add the 10 minus the 8. And so this is my answer. 1,131. Yeah. So, I mean, when we break it down, you could do this, not a problem. But I think it's a little bit making it more complex than it really is. And then there's a bunch of like others, like, well, let's grab there's the graph, and then let's start like bringing it all in and all this stuff. It's like, yeah, oh, okay, we could. So it's I think it's getting to be a little bit more complicated, because the human brain only sees like 5 things really. Right? Like, it only focuses on 5 items. So even like when the numbers get bigger. So anyways, okay. Thank you again for everybody showing up. Thank you again. Thank you for all the hearts, and thank you for all the questions. I really do enjoy the comments and the questions, and anytime you have questions about it. Rachel, if you're looking for something to bring into your school, let me know. We can talk about like a curriculum. I have something in my head like how it would go, but I couldn't figure out like how to make it into more of a curriculum. So like this one was more of a curriculum for the kids that are young, for preschoolers, and I think for preschoolers this would be good for like a year, because it's talking about the adding, talk about the adding and subtracting towards the end. But what it was, and then I have the other ones, which is plus 5 and then the plus 10s. I am working on the other books. It's just finding the time, and so there's like a whole. I'm trying to build my series out, but it'll be interesting to see how you incorporate Abacus to your school, your class. Let me know. All right. Thank you everybody for joining. I'm not sure if Rachel's still around, but thank you again for joining. Thank you for Mini-verse Delicious and Andrea and Sonic the rock hog. Amma, I'm glad to see you here, and Morwa, thank you so much. I appreciate the questions, and thank you again for joining me, and I will see you next time. Have a good day, have a good night, have a good morning to everybody, and I will see you later. Bye! End live. There we go. End the live.